We'll be talking in this video about properties of logarithms, so just kind of typical to look for, maybe to make your work a little bit faster. So across the top here, we have 4 different examples, so let's play around with them. So first we have the exponential equation 2 to the 0th power equals 1. It says write in log form. So if I'm going to convert this into log form, I'm going to write log base 2 of 1 equals 0, right? Now, if we want to generalize this, we could say that log base b of 1 equals 0. It doesn't really matter what the base is, right? Because any positive base raised to the power 0 equals 1, right? So 5 to the power 0 equals 1, 20 million to the 0th power equals 1. So if we think of it in exponential form, we know raising a base to the 0th power gives us 1. So flipping that into log notation, any logarithm base b of 1 is going to equal 0. Remember that a log is an exponent. So if the exponent is 0, raising a base to that power 0 is going to give us 1, right? So down here in these numbered examples, let's take a peek. Like here, number 19, it says log base 6 of 1 equals. Once I kind of get comfortable and I don't want to say memorize, but get used to, internalize this property, I can see right away that log base 6 of 1 equals 0, right? If I were to convert this into an exponential equation, 6 to what exponent equals 1? 6 to the 0th power equals 1, right? The log is the exponent. All right, so let's take a look at our second property. So up here at the top, it says write in log form 2 to the 1st power equals 2. So if I want to rewrite this in log form, I'll switch colors just to keep it jazzy. So if I'm going to rewrite this in log form, I'll have log base 2 of 2 equals my exponent of 1. So log base 2 of 2 equals 1. And again, we could generalize this down here. Log base b of b equals 1, right? Log base b of b equals 1. No matter what the base b is, if we take b and raise it to that exponent of 1, we're going to get b, right? So a base raised to the 1st power is that same base. So if you're taking log where your base and your argument are equal, the result is going to be 1. You're going to evaluate that log and get the result of 1. So let's take a peek. Let's see, number 18 is an example of this property. So log base 5 of 5 equals 1. So knowing that property, I can identify that quickly. I can get to my answer 1 right away. If we want to break that down and remind ourselves of why that's true, our base 5 raised to the exponent 1 equals 5, right? 5 to the 1st power equals 5. It's not as obvious, but if you take a look down here at number 21, this is another example of this property in action. So remember that the natural log, ln of e, natural log of e, if we wanted to, this would be totally improper, so don't actually like write this on an exam or anything, but we could think of that as log base e of e, right? I'm going to put that in quotation marks because that's not really the proper way to write it. But remember that natural log is like a log base e. So if we're taking natural log of e, that's kind of like thinking log base e of e, which gives us 1, right? Because e raised to the 1st power is e. All right, let's take a look at our next example here up top. It says write in log form 2 to the power x equals 2 to the power x. So if I want to rewrite this in log form, and just because this one's getting a little messy, so that's going to be my base, x is my exponent, and then this 2 to the x over here is going to act as my argument. Okay, so I'm going to have log base 2 of my argument 2 to the power x equals my exponent x, if I'm rewriting that in log form. And generalizing, here I have log base 2 of 2 raised to the power x on the left side. If I generalize that down here, I can write this as log base b of b raised to the power x equals x. So what I want you guys to look for is anytime you have matching bases, the base of your log matches the base of your argument, that's when we can apply this property. I'm going to erase that just because it looks really messy. All right, so log base b of b to the x equals x. Let's think about why this works. So b, my base, right there, the little base, b raised to my exponent, x, equals my argument b to the x. So it looks kind of like overly intuitive, b to the x equals b to the x. Of course, it says the same thing on either side. But again, what we're looking for is when the log base and then the base of the argument match, then we get that exponent out as our log. Remember that a log is an exponent. So if we take a look at example 17, log base 7 of 7 to the 4th equals what? Applying that property, my exponent is 4. So why is this true? If we convert this equation back into exponential, just to check it, my smaller base of 7 raised to the power of 4, so 7 raised to the power of 4, equals my argument, which already had 7 to the 4th power. And of course, 7 to the 4th equals 7 to the 4th, right? Sorry, those arrows look crazy. They're a bunch of arrows. We're in Arrow Town now. Let's see, if we go over to number 22, this is another example of this property. And again, even though we're not really going to write it like this, let's just pretend like we're writing this natural log as log base e of e to the power 2x. Notice that the base of the log and the base of the argument match. They're equal to each other. So that means that we get our exponent of 2x. All right, so let's look at the true weirdo in this section. This final example over here in the top right. It says write in exponent form, and we have log base b of x equals log base b of x. I'm going to give you guys a little bit of a warning here. This example always reminds me a little bit of a snake eating its own tail. I don't know why. So it's going to seem a little kooky, but just bear with me. It's like complicated but simple at the same time. So we've got our base. All right, so here's our base b. Oops. There we go. So that little base b is going to be our base. This x here is our argument, because remember we're in log form. And then this whole result to the right-hand side, that's our exponent. I'm just going to write exp. So that's our exponent, right? Because a log is an exponent. So we take log base b of x, and we get our exponent, which is log base b of x. All right, so I'm going to rewrite it in this form using that base, that exponent, and that argument. So our base b raised to the exponent log base b of x. So yes, that is a subscript in a superscript. Bear with me. So b raised to the power log base b of x equals x. Isn't that pretty? All right, we just have that same exact property rewritten down here. So before we get too deep into this, I want to use like actual numbers because maybe that'll make this a little bit easier to digest. So what I want you to focus on is the two b's match, the base of your exponent and the base of your log match. And then the x in the log and then the x as the exponent, those are going to be identical as well. So if we have a base of 2, let's say, 2 raised to the power log base 2 of 8. According to what I'm seeing up above, that should equal 8, right? The 2's match, and then just like the x's match above, in theory, the 8's should match as well, right? So because I'm using real numbers here, let's just double check this and make sure that it does work and that I'm not totally wrecking this. So if we look at that exponent, log base 2 of 8, if I were going to just simplify that, log base 2 of 8 would be 3, right? 2 to the 3rd power is 8, so log base 2 of 8 is 3. So this is just saying 2 cubed equals 8, which we know is true. So hopefully it's a little easier to see with these numbers, but what I want you guys to focus on is in these equations, if you have a base matching the base of the log up in the exponent, and then these arguments will match. The argument of the log will match the result, the result on the right side, I'm gonna call it. Okay, so let's take a look at number 20, and I'll pick this yellowy color again, so number 20. All right, 3 raised to the power log base 3 of 9 equals what? So copying off of this property up above, we have the matching base 3's, so that tells me that I'm gonna have a 9 on the right side of this. But let's break this down and see why that result is 9. So this says 3 raised to the power log base 3 of 9. Let's just isolate that log base 3 of 9 for a second. Log base 3 of 9, if I were going to evaluate that, I know 3 squared equals 9. So that's just a 2, right? A log is an exponent. 3 raised to the exponent 2 is 9. So all this is saying above is that 3 raised to the power 2 equals 9, which we know is true. Saying it in a way more complicated way, but it's an equivalent equation.